Web application development is a massive field with an estimated 28 million web developers worldwide. And, for better or for worse, much of the modern web is built on JavaScript. JavaScript is, in my opinion, aggressively fine. It gets the job done. But JavaScript applications are often prone to runtime errors and ballooning state management systems. Some of its drawbacks are alleviated by TypeScript, but TypeScript isn't perfect, and it isn't totally type-safe either. This is where Lustre comes in, a new web application framework that thinks about things a little differently. Lustre is written in Gleam, a functional programming language with an excellent static type system. This video is the first in a series of Lustre videos where I'll be digging deep into the framework's capabilities and showing you how to build beautiful, scalable web applications in Gleam. If you're ready to shine, let's go. Lustre is modeled after a web development pattern popularized by the Elm language and commonly referred to as the Elm Architecture, or TEA. In the Elm architecture, your application is made up of three main components: the state, an update function, and your view. Your view is what produces your UI, usually by generating HTML, and is a pure function of your state. This means that the same state will produce the same view every time. We change state using the concept of messages, where each message describes a state change. Messages originate in the outside world and may come from your front end, like when a user clicks a button, or from your back end, say from an update in your database. They're passed into your update function with the current state, and a new state is returned. You don't need to worry about handling all these messages though. The Lustre runtime will do that for us. It's also important to note that each app typically has a singular piece of state for the entire application, rather than breaking things down into stateful components, like you might in modern JavaScript framework. Apps with multiple routes will generally have a submodel for each route, but this will still sit within the main model. This is a bit of a departure from what most people are comfortable with, but once you start drinking the tea, you'll realize just what you've been missing out on. Now that you're a bit more familiar with Lustre's underlying patterns, let's get started with our first Lustre app. We're going to be building a single-page Pokédex app that allows you to search for Pokemon and get some stats about them. This project will use a subset of the Pokemon API that I built as part of a previous video, but you don't need to know the specifics to follow along here. The code is all on GitHub with instructions on how to run everything. Create a new Gleam project using Gleam new Pokédex, then install Lustre using Gleam add Lustre. Lustre also comes with some excellent dev tools that we'll use to run our app. Install them with Gleam add --dev Lustre dev tools. As a quick note, if you're on Linux, you'll need to install iNotify tools if you want hot reload. You can generally install this with your usual package manager. The last step is to change your target to JavaScript in your gleam.toml file. Unlike other type-safe frameworks you might see in Rust or Go, Lustre doesn't compile to WebAssembly. Instead, it uses Gleam's built-in JavaScript compiler to generate JavaScript. Unlike TypeScript, Gleam's JavaScript is type-safe, and you get Gleam's excellent error handling construct baked right in, so you know that if your app compiles, it'll run. But that's enough talking. Let's get something up on the screen. If we open up our Pokédex.Gleam file, we'll create the simplest type of Lustre application. This has no state and just produces a static page. Define your app using the Lustre.element function using a HTML.h1 from the Lustre element HTML package. Then, start your Lustre app using the Lustre.start function. This takes your app instance, a CSS selector, and some initial flags. The CSS selector defines the target element for your Lustre application and should be #app by default. We'll get into how to customize that later. The last argument can be of any type and allows you to pass arbitrary startup config to your Lustre application. We don't need these today, so we'll just use nil. Finally, we'll run our app using Lustre's dev tools. Do this using Gleam run -m lustre/dev start. And we have a heading. If we change the text in our code, it'll hot reload and update on the page immediately. Nice, but I want a bit more styling than just the browser defaults. There are a few options here, including hand-rolling your own CSS. I hate CSS though, so I'm not going to do that. Instead, I'm going to use another tool. Lustre's dev tools have built-in support for Tailwind CSS. Simply run Gleam run -m lustre/dev add Tailwind to get started. This will download a Tailwind binary and create a Tailwind config for you. The last step is just to reference the generated CSS file in your index.html. The index.html file in the root of your project directory is automatically generated by Lustre and contains your app scaffold. You can use it to add to your page head, like we're doing here. It's also where you can add a custom app target element if you don't want to use the #app selector. Now we can add some Tailwind styles to our header, giving it a pop of color, and suddenly things look a lot better. But this is still boring. It doesn't do anything. Let's add some user interactivity. But first, I wouldn't be able to live with myself if I didn't tell you about today's awesome sponsor, Codecrafters. If you're not already in the know, Codecrafters is a learning platform for advanced software engineers. Unlike platforms that keep you in tutorial hell, Codecrafters challenges get you focused on building software with real-world applications. One of my favorites is their Redis project, which they've recently released for Gleam. You'll be given pointers on how to implement your own Redis clone in Gleam without being spoon-fed all the answers. And once you've got your code, It's a simple git push to CodeCrafter's custom Git server to have your code tested. If you pass, great, you can move on to the next step. Stuck? No problem. CodeCrafter's community members often share their solutions, so you can see how other people are tackling the exact same problem. If that all sounds good to you, head to ihh.dev/codecrafters to start your free trial. And if you sign up at the end, you'll get 40% off whichever plan you choose. CodeCrafter's memberships should also qualify for reimbursement through your employer's learning and development budget, so it won't cost you a penny. And as a bonus, you'll be directly supporting the channel, helping me bring you more epic Gleam content. That's ihh.dev/codecrafters. The link is on screen and in the description. But let's get back to our Pokédex. In order to add interactivity, we need to define a model type. This acts as the type for our app's state, and you'll get very familiar with this as you build out your Lustre application. The only state we need for our Pokédex is the currently selected Pokemon and a list of all currently available Pokemon. We'll use an option type for the current Pokemon field in case the user doesn't have a Pokemon selected. These are all just strings for now, but we'll use a more complete Pokemon type later when we start talking to the API. Now that we have a model, we need a way to set our default state when the app starts up. We do that by defining an initializer function, which we'll call init. This needs to take in a single argument, which is the flags value we spoke about earlier. Since we're not using this, we can just prefix it with an underscore to tell the compiler to ignore it. We'll then return our default state, which has a pre-filled list of some of my favorite Pokemon and no current selection. Next, we'll create our view function. This takes in our current state and returns some HTML. I won't go into everything in the video, but I've broken our view out into a few functions for readability. The header function contains the header we were discussing earlier, and Pokemon details and Pokemon list return a view of our currently selected Pokemon and the list of all available Pokemon, respectively. We've now got our state and our view, which comprise two of the three things we need for an interactive Lustre application. The last is the update function, which handles messages generated in our app to update our state. Let's define our message type. For now, we only have one message type for when the user selects a Pokemon. It's good practice to name your messages in the subject-verb-object style, so you can easily tell how the message was triggered and what action it pertains to. This message is called user-selected Pokemon, and it holds a string, which is the name of our Pokemon. We now need to define our update function, which takes in a message and uses it to create an updated state. We'll use a case statement to allow us to match against future values, and the user-selected Pokemon message will just set the current Pokemon field to its contents. To use all this in your app, change your lustre.element function to lustre.simple in your app definition, and that's it. We're all set up. If we look at our app again, it displays all our Pokemon nicely and tells us that there's no Pokemon selected. So if we click one of our buttons, nothing happens. We've told our app how to handle our user-selected Pokemon message, but we're not actually using it anywhere. Thankfully, it's an easy fix. In our button view function, we use an event.onClick from Lustre event to add a click handler to our button. This just takes a message to send when the button is clicked. So we'll use user-selected Pokemon with the same Pokemon name we're displaying on the button. Now, if we run the app again, we can switch between Pokemon. So far, we've set up a single page app that can take user input and update the UI reactively. That's great. And for some apps, that's probably enough, but it's not good enough today. We have an API that's waiting for us to talk to it. It's been so lonely for so long. One way you might think of approaching this is by making the API call in our update function. However, the update function runs before the view updates, and if the API call takes some time, this would make our app feel really slow and unresponsive. All we need is a way to run the API call in the background and have that send another message at a later time. Thankfully, Lustre allows us to do this with effects. An effect is usually an IO-bound background task, and it can run once and end, or it can stay alive in the background, potentially sending multiple messages back to our app, like with a WebSocket connection. In our case, we just want to use effects for API calls, and while we could write these effects ourselves, there's a package for that. Add it to your project using Gleam add Lustre HTTP. We also need to move to our final app constructor of the day, so replace lustre.simple with lustre.application in your main function. This will cause some type errors, so let's get those fixed. The problem is that lustre.application expects your init and update functions to return a tuple containing your state and an effect to run. For now, we'll update them both to return the same values they were returning previously alongside an effect.non value, which is basically a no-op. Since we're now going to be getting more data than just our Pokemon's name, we can update our model to use this new Pokemon type. The Pokemon type is the same as what we get back from our API and just has the Pokemon's name and its stats. I've also created a decoder to create a Pokemon from the JSON we get in the API response. In order to use this effect in our code, we first need to create one. We can do this using Lustre HTTP quite easily. The expect.json function takes in a decoder for your type and a message constructor. It'll decode any JSON response from the API using this decoder and use the constructor to send the message. In this case, we can use our Pokemon decoder and a new API returned Pokemon message type, which we'll define in a minute. Then we simply return the result of Lustre HTTP.get, which will be a Lustre effect, which is generic. over our message type. This will run the API call in the background and send a message when we're done. As for the message itself, Lustre HTTP requires that it contains a result. The OK variant should be the type returned by the decoder we used, so a Pokemon in our case, and the error variant is a HTTP error. Going back to our update function, we can change our user-selected Pokemon handler to return the model as is, along with the fetch Pokemon effect. The API returned Pokemon message has two branches in our case statement. One for the OK variant, which does what user-selected Pokemon used to do and updates our model with the current Pokemon, and for now, error just sets the current Pokemon to none. We'll also update our model to take a Pokemon instead of a string, and update our view to display a little more information. In our app, we can see that we now fetch Pokemon information from our API. We now get the Pokemon stats as well as just a hard-coded name. It does take a second to switch to a Pokemon that we don't have cached, and it would be nice to have a loading state. I've implemented this in the final app as well as an error state, but I'll leave it out here so you can try and figure it out for yourself. I've also implemented another fetch call to get a list of all the Pokemon currently stored in the API's cache and use that to generate the sidebar list. In order to get the API call to happen on load, I just return the effect from the init function, but otherwise the logic is pretty much the same. I've also changed the API returned Pokemon message so that a successful call will fetch the list again, but only if the returned Pokemon isn't already in the list. But in order to get Pokemon not in the list, we need to be able to search for them. Thanks to the way we've set this up, we can easily hook up a search input and a button. First, we update the model to include a Pokemon search value. We create a couple of new messages, user updated Pokemon search term and user clicked search button. The former is linked to a model's search value and updates it on input, and the latter submits an API request when the search button is clicked. We also reset the search term just for a slightly nicer experience. And that's pretty much it. Like I said, there are more Lustre videos incoming, so if you're interested in those, make sure to subscribe so you don't miss them. Hopefully by now, you've been convinced to try Lustre for your next single-page application. I think the real power of Lustre is the model view update architecture combined with Gleam's excellent type system. It makes adding or refactoring functionality a real breeze, and you'll find you can create nice user experiences pretty simply. As a bonus, Lustre apps just compile to HTML, JavaScript, and CSS files, so you can host them statically on something like GitHub Pages. What do you think? Will you try it out? Let me know in the comments. And don't forget to check out Codecrafters if you fancy taking your programming skills to the next level. Just head to ihh.dev/codecrafters to get started. But for now, if you're interested in how the backend API for this project works, you might enjoy the video on the left, and YouTube suggests the video on the right. See ya!